Hey, how you doing? My name's Elton. Welcome to Learn Docker in a Month of Lunches. This is episode 18. And we are very near the end. So we're just wrapping things up this week with some really important topics. So we're looking at production readiness. So if you've been kind of following through the series so far, you've learned a ton of stuff about Docker, about the technology, about the practices, about some of the ways you can use it and the things that it enables. And the goal really is to get you comfortable with doing your own proof of concept with your own applications, but then knowing that what you need to do after the proof of concept to know what takes you to production. And that's what we're covering this week. So today is all about logging, which sounds boring, but isn't. So stick with me because we're not just going to be looking at loads of log files. The whole point of Docker is that because everything is running in containers and it's being managed centrally by the Docker engine, Docker can scrape up all your logs and forward them somewhere else. So you can really easily, you can have a centralized logging database with a front end to search for all your logs for all of your applications, and we'll see how that looks today. Okay, so if you're a familiar viewer, you will know how this stuff goes. So I'm going to start with my little look around the website for the book. So this series is a serialization of my book, Learn Docker in a Month of Lunches. This is the homepage for the book. We'll just see what's going on there. That's where all the links are to find all the resources about what I'm doing. We're focusing on chapter 19 today, which is writing and managing application logs with Docker. And then there's some Q&A at the end. So in the YouTube chat or in the Slack channel, ping me any questions you've got. I usually go on for 55-ish minutes. If there's time at the end, if there's interesting stuff to talk about, then we can talk about that. Okay, let's get on with the chapter. So first of all, we're going to go and look at DIAMOL.net, which is the website for the book. There's all the links here to buy it from Amazon or Manning. There's some discount codes there for you. If you don't want to buy the book, that's totally cool. Here there is a link to my GitHub repo, and that's where all the sources for the book are, all the Docker files, the compose files, all the source code for the demo apps, everything is in there. You can watch all the episodes that I'm streaming on YouTube, and down here, these are all the episodes I've done so far. Seems like a busy month, but we're getting towards the end now. So by the next 2 more episodes, and we'll be wrapping this up. There's a little bit about me. So I do this, I do training, I do freelance consulting. So if you want somebody to come in and help you on your container journey and show you where you are and how to get to where you want to get to, that's the sort of thing I do. But I'm also a trainer. So you'll see a bunch of my stuff on Pluralsight. That's my blog, and this is where I live on GitHub. Okay, that's it. That's it for the adverts. So let's get back to the chapter. So today we're on chapter 19. When I wrote this chapter, my son came in and looked at what I was writing and said, "Dad, you can't write that your stuff's boring in your book." Well, I'm not really saying it's boring. Logging is typically not a very exciting topic, but it's crucial. It's the other half of observability. So we've already had an episode about monitoring where we looked at Prometheus and how you put your metrics endpoint in all of your application components. You run Prometheus, it scrapes everything. You build this lovely dashboard, and that tells you the overall health of your application. But when things go wrong, it's not going to give you enough detail. It might, ideally, if your dashboard will show you the time frame where something happened. Maybe you can correlate that to a new release. But if you really need to dig down, then logging is the next level. And remember, monitoring is a sampling thing, so you don't get every single piece of information. Whereas with logging, you do. Every log entry should be able to be collected and forwarded. So this is where things get interesting. Docker has this pluggable logging framework. So I can tell Docker, when I'm on my Docker container logs command, Docker's putting the logs out that my application's writing, and I can tell it to forward them somewhere. And Docker has this kind of plug-in model with a whole bunch of interesting things already supported out of the box, and it just sends your logs to some sort of data store, and then you do whatever you want with them. And it's not any difficulty to set that up, as we will see. Okay, so we know, because we've been following along, that a Docker container is just this kind of virtualized environment around your application binaries. And when you look at the logs for a container, what you're actually seeing is whatever the process inside the container is pushing out to the standard output streams. So standard error, standard out. That's where Docker looks to see where these things come from. So if it's a modern application, like that runs as a console application, so like think of Node.js or Go applications or .NET Core or even Java, they run as a kind of front-end process. So the Node process or the .NET process is the actual thing the container sees. So anything that comes out of that process, which is the runtime for your application, those are the logs that Docker sees. So when you do your logging entries, they come out into the container, everything works really nicely. So ideally, then there's nothing particularly difficult to do. But in some cases, you don't get that. In some cases, your application doesn't write to standard out, and we'll see how to deal with that too. But let's just stick with the basics for now. So I'm going to run a really simple container. So just like always, I've tested these exercises, so I've already pulled the image. When you run this yourself, you'll get exactly the same output, but you might be pulling the image first. Okay, so I'm running an interactive container, so it's not detached, so it's running in the foreground. It's a .NET application. All it does is every 5 seconds, it prints out the time. It's not super useful. There's a bunch of other things that it prints out too, and they're all configurable, so I use this little demo apps like this to show configuration and stuff. So it's just going to keep on running. Inside the application code is just like a console write line statement to write out this thing on a timer, and the Docker file just runs a command to start the .NET application. So there's nothing special to happen. If the application is running in the foreground, so it is the process that Docker starts with the command instruction, then whatever comes out of the standard out, Docker sees. So I can Control C at this point, or Command C if I was on Mac, and that ends the process. So it ends the container, and that container gets exited. So you see, again, if this is the first time you've watched this, then every single exercise has a screenshot with a bunch of annotations in the book chapter, so that you can see what I did when I ran the exercises. So if something goes wrong when you're doing it, then you can kind of help you to see what's happened and debug. So this is the thing that I'm talking about here. Most of the apps that I've used, or all the apps so far, kind of follow this pattern. The process runs in the foreground, so in your command instruction, start your application, and the app is configured to write log entries out to the console to stand it out. But what Docker actually does is Docker kind of pulls those log entries out and stores them in a JSON file. So even when the container is not running, so when the container has been exited, those log entries are still around while the container lifetime is still there. So there's a little picture here where we see that. So inside here, I've got my container. Inside the container, there's the application process, and it's writing to those output streams, standard out, standard error. There's nothing special about that. That's how the applications have communicated with users since forever. Those same streams are on Windows and Linux and everything else. So Docker is looking at those standard output streams, and it collects them, and it stores them somewhere, by default in these JSON log files, but that's the bit that's pluggable, so it can collect them and forward them somewhere else. Okay, so if I try this again, we'll prove that these things really do carry on even when the container's not running. So same application, but I'm running it detached, so it's going to run in the background. It's still going to sit there every 5 seconds inside the container. The application is going to write out this console entry to standard out that just prints out the time. So if I look at the most recent logs, this same Docker container logs command, I've got the tail parameter here saying just get me the most recent log entry, and then the name of the container, which I set when I ran the container. So I'm looking at the time check container, the most recent entry, again, same thing, just shows me the timestamp. Okay, so if I stop the container now, so I'm going to stop that time check container, it's not going to write any more log entries. The container still exists, but it's in the exited state. But the log files still exist too. So I can go Docker container logs again and look at the most recent log, and it was 10 seconds after the previous one. So the application carried on running until I stopped the container. There's no application running anymore. There's no CPU or memory that the container is using because there's no compute, but the logs are still stored in those log files. I can still see them through Docker. And I can also inspect the container. So we've seen the Docker container inspect command just prints out a huge wodge of JSON, but you can give it a format like this. I'm telling it the format string. I just want to see the log path. So as part of that huge wodge of information, Docker tells you where it's storing the log files for each container. So in this case, I'm running Docker Desktop on Windows, but in Linux container mode. So the way that works, it kind of feels like everything's just working normally, but there's a Linux kernel running inside my Windows 10 machine. That's the Linux operating system that is running the containers for me. So Docker Desktop makes this super easy to switch between Windows containers that run directly on your Windows operating system and Linux containers that run inside of a virtual Linux environment on your Windows machine, which might be WSL, the Windows subsystem for Linux, or it might be Hyper-V, depending on the version of Windows that you've got. So I can't go and look at this file because it's part of my WSL environment. But if I was running Windows containers, if I was running Docker CE, I would see a path to a file that I could go and look at. And actually, in my screenshot here, when I did the recording when I did the chapter, I was running Windows containers, and you can see here I get the same sort of output, but the way that you work with containers is the same. But Docker is storing these inside the C program data Docker containers folder. And the path ultimately contains the container ID. But I could go and look at those files, if the container is running directly on my operating system, and go and see them. And what they contain is just a really simple JSON format. So I can see the entry itself. So that log field tells me the entry, and then it tells me which stream it came from, standard error or standard out, and then a time check, which is a UTC time check, which because the log entry itself might not have any time. So mostly it's the log entry and these couple of extra bits of metadata. And that's the same for every application that's in your container, everything that comes to standard out, whether it's printed out as part of a startup script. So we talked in the previous episode about how your command instruction might do some setup work before it runs the application. If you've got some sort of script running or a utility that prints out lines to standard out, Docker will collect those. And then when the application itself runs, whatever it prints to standard out, Docker collects those too. So it doesn't matter what is writing to standard out, as long as the process that Docker is watching, the log entries are coming out, then they get stored. Okay, so Docker actually doesn't just have this one big file that fills up your disk. It has like a rolling log file thing, and you can configure how the Docker logging works. And that's done at a kind of per container basis, or you can put defaults in your Docker daemon configuration, your daemon JSON file. So in this case, we're going to run that same container image again, but with some logging options. So what I'm saying is I'm running it in the background. I'm giving it a name. I'm saying that this log option, the maximum log size, the maximum size for a file is going to be 5K. So instead of the default like 100 meg or whatever it is, nice small file. And I'm saying I have a maximum number of 3 files. So it's going to roll over as soon as the log file fills up 5 kilobytes. Docker will roll over and start a new log file to a maximum number of 3. And after that, old entries get truncated. So only the new ones get stored. And then this environment variable here for the application. So this is just a bit of application config telling it to run its interval on a very short interval. So there'll be lots of logs. There'll be a log entry every second. They get written to those JSON files. And as soon as it fills up 5K, then Docker will roll over and create a new log file. Now, I'm not gonna wait for a few minutes and talk about the weather or anything like that. I'm going to go straight and check the logs, and we'll see from the screenshots what would happen if I had waited. So in this case, when I go and look at the log path again, so just seeing where Docker is storing those logs, I get a single file that comes out, and I would still get a single file that comes out even if Docker was writing multiple files. If I go and look at the actual folder, which I've got here, when I'm running around this on Windows, I did the Docker container inspect. It gave me a single log file in that path. When I go and look at the contents of that particular directory, I can see there's a .log file, a .log.1 file, a .log.2 file. So those are the older rotated files. If I left this running long enough, then it would fill up the 5K, and then Docker would rotate. So the JSON.log file is the current one, and then it goes, the previous one is the .1, and previous to that is the .2. So you can configure all these pieces, and that's on a per container basis. So any other containers that I run now will just use the defaults. Okay, so this is the bit that's important. So those options that you're setting, those logging options, tell you that there's something happening in between Docker collecting the logs and doing something with it. And that's this kind of processing stage where Docker has got the log entry out from the standard output, and it's going to do something to it. It's going to collect it and process it. And it's going to write it somewhere, maybe to a JSON file and maybe to somewhere else. That's the important bit to remember. So that JSON file structure doesn't do very much, but you can do other things with it. Okay, so before we go and look at the more fun things, lots of applications don't really fit that nice model where, there's an app running in the foreground, it prints log entries to stand that out, and everything's hunky-dory. Older applications may run in the background. So if I'm running a Windows application, it might run using the IIS web server, and then that's running as a Windows service, even inside a container. So that's like in the Linux world, that would be a background daemon. So imagine my startup process inside my container is not my actual application process. So whatever log entries come out from standard out, they're not my application. They're just something else, some sort of utility that's keeping the container alive. My real application is sat in some other process that Docker knows nothing about. So that's one use case. I need to get those log entries from wherever they come from. And the other use case is like a kind of fake one here where the application is running in the foreground, but it's configured not to write to standard out. And you'll see this all the time as you move more and more apps to Docker. Some of your applications just won't write to standard out. They'll write to a log file, or they'll write to the Windows event log, or they'll write to syslog in Linux. So they're using different syncs, is the term that you get in the logging world. So they're going to different places, but Docker doesn't know anything about them. It only knows about standard out. It's the only place it looks. So if we run a container which does not behave in the way that Docker kind of expects, so I'm going to run, this is version 4 image. So same application, but this one's got a slightly different configuration. And what it does is it writes log entries to a file inside the container file system. And Docker knows nothing about that. It doesn't care what's in the files. It's not going to go and read a file by default. I can't configure it to do that. If I go and look at the logs, it's still doing the same thing. It's still writing this entry every 5 seconds, but there are no logs. And I can wait as long as I like. And there will never be any container logs because the process itself never writes to standard out. So I can go and see that the container is actually writing logs if I go and connect to that container. So we've covered this before, but docker exec runs a command. I'm running interactively, so I'm going to connect to it, and the command I'm running is just a shell, the Linux shell. And if I was running in Windows containers, there's an alternative command here that would drop you into the Windows command line. So I'm inside the container now. So if I have a look at the path, which is where the application log, I happen to know it gets written there. If I go and look at my timecheck.log file, everything's in there. So the same thing that I've seen before, all these log entries with the environment and the version and the time check, and they're being written every few seconds, but Docker doesn't know anything about them. Okay, so the sync is this file, and Docker doesn't know what to do with that file. Docker doesn't even know that file exists. Okay, so this is the kind of example that the pattern for dealing with this is to have another utility. So the startup process, whatever you're running in your startup process, it could be a script or it could be a utility written in the platform that you're using. That is the thing that's going to write your log entries. That's going to write to standard out, and it fetches the actual application logs from wherever they're being written. So it's like an adapter that fits into your container image, and it knows that the log entries are coming into the event log or syslog or a log file. It knows where they are, and it reads them on a loop, and it just relays them back out. So it reads the log entry, and it writes them to standard out. And so Docker sees that. So this is not ideal. Let me show you the diagram to make sure we're clear on what we're talking about here. So in this case, in my Docker, when the container runs, my application process in the container is writing to a log file. So Docker knows nothing about that. It won't get those log entries, but I've got this log relay utility that's reading from the log file and pushing the log entries to standard out, and Docker will see that. Docker doesn't care that it's a different process from my actual application. All it knows is that the process that it's monitoring is pushing out log entries to standard out, and that they get collected as logs. It's not ideal because, for two reasons, that utility is the foreground process. So whatever you're running, if it's just a little script that does a tail, or whether it's something more elaborate, that's the thing that Docker's watching to make sure your application is up and running. Because remember, when the process in the container exits, then the container exits. So if your utility fails for whatever reason, then your container is going to exit, even though your actual application process might have been fine. So this thing needs to be robust. And the other thing is, of course, the reverse of that is also true, that if your utility is working fine, but your application process has crashed, Docker doesn't know anything about that. And that's where health checks come in. So we've already covered health checks. They're really important when you start to monkey around with your startup process in your container. So if my startup process is doing some other things, then it could very well be that what Docker's looking at to make sure the container is still up is not my application process. Then I need a health check so that Docker is testing the right thing is actually healthy. The second thing is, this is not efficient in terms of disk, because what happens is I'm writing inside my log file inside the container, so I'm using up disk on the machine that's running the container. And then Docker's scraping these things out and storing them in its own JSON file, so I'm duplicating all that stuff. That shouldn't be less of a concern, because remember, we've talked about you're gonna replace your containers pretty regularly. You're gonna have an automated process. So every month, when the operating system gets an update, when your runtime gets an update, when you've got a patch to do for a library that you're using, you're going to roll out a new container and replace the previous one, and all your logs will go. Your logs that were in as part of the container. So that should be less of an issue. But bear in mind, this is a suboptimal thing, but it means you don't have to change code. You don't have to change what your application currently does to bring it into the world of containers. You can bring it in as is, and then piece these bits around it. Add the health checks in, add the monitoring, add the logging and the configuration setup that we've looked at to make sure that it behaves like a new application that was container native, but without having to change the code. So that's what we're talking about here. So, and in my example here, again, it's .NET. There's all sorts of different examples in different languages throughout the book, but .NET's my main language. That's why most of them are in there. So in this case, what am I looking at here? I'm looking at my utility application. So my Dockerfile v5. We've talked about utility kind of pieces before, where the idea is that I've got several things that my container can actually do. In this case, I've got a builder stage that's going to compile my actual application. That's my time check application, the thing that just writes the logs. And then I've got this little utility that does the tail. Effectively, it just watches the log file and writes it back out to standard out. So this is the relay utility. In Linux, there's a shell utility called tail. There's something kind of similar you can get in Windows with PowerShell to read the content of a file with the follow flag. But this is a cross-platform way of doing that. So when we talked about multi-architecture images, if the utility that you're building is cross-platform, then you can run this stuff anywhere. Okay, so then we've got my application image that's got all these various bits and pieces that we talked about before, like labels and all this good stuff. And somewhere down here, I've got my command startup. Now, there's an interesting bit in here because even though that I'm trying to make this cross-platform, actually it isn't. Up until this point, it is. So all the building of the utility and all that sort of stuff, but the commands are slightly different because the way I'm starting my my log process in the foreground, and I'm starting my application process in the background. And the terminology for that is totally different in Linux and Windows. There's no way around that. So in Windows, I do a start/B to put my my actual application in the background, so it's running in the background, and then I run my tail utility to relay the logs in the foreground. Now the Linux version is doing fundamentally the same thing, so it behaves in the same way, but the way that you do it in Linux is you do it with a single ampersand. And there's no way to translate that to make it work on both systems. So I start the time check in the background, and then I start the logging entry. And I'm using, we talked about multi-architecture images where you can have these named stages, and then you build to one stage or the other. That's how I do the multi-arc bit for this particular image. Okay, so let's close that down. So we've seen how this looks. I didn't close it down, I opened it up. So those two command instructions, the goal is to achieve the same thing. Fundamentally, whether you're running Linux or Windows, you'll have the same experience. Okay, so I'm going to run this from version 5. This has my utility that's going to relay my log entries. So I should see now, I'm running it in the background so I don't get anything out. I'll wait for a second. I'm going to have a sip of water while I wait. And now I should have some log entries. So I've got my log entries back out. So it's the same application that's writing to the log file inside the container. But now I've got this utility application that's relaying the logs back out. And if I do, what did I call it? Time check 4. If I do, I'm going off script here. If I do a Docker top to see what's running inside that container, I'll see I've got two things. I've got the .NET time check DLL, which is the binary that's running my application in the background, and then the .NET tail, which is in the foreground. So that's running both those processes. It's fine to have multiple processes. It's not a problem as long as you're aware of the fact that Docker is only watching one of them. If I go and connect to that container, and again, this is the Linux version, so I'm inside the container here. And if I go and look at the log file is still there. So the application is still doing what it did last time. It's just writing to this log file. And then the utility, which is like in Kubernetes terms, this could be a sidecar running alongside the application, is putting the logs out so that I can get the logs into my container platform without changing the code or the setup of the application itself. Okay, so let's leave this container. So that's the kind of basics to make sure the goal is basically simple. Make sure when you do Docker container logs, you see the logs for your application, and that's really it. There's a couple of patterns for doing that. This log relay utility is the less preferred one, but it will get you up and running. It'll get your app behaving like an ordinary container app. Okay, so when you've got all this stuff done, that's when you can start doing the interesting things. So I talked about a long time ago, one of the big benefits of Docker is it adds this consistency across all your application landscape. So every application component has a Docker file. Every application has a Docker compose file that describes how all the bits fit together. Use the same tools to build them and to manage them in development environment, in the CI process, in production. So you get all this consistency. Doesn't matter what's going on inside, whether your container is running your 15-year-old Windows.NET app or your brand new Go application. The commands are the same, the API is the same, the artifacts are the same all the way through. And again, Docker doesn't care what's running inside those containers, but it knows that there's this kind of interface that it expects the application in the container to honor, and logging is one of them. It expects to get the log entries out in standard out. And so, because as long as your application fits into that, then you can do nice things with Docker. So we can pull those logs out and put them somewhere central. Now, the components to integrate with Docker to pull the logs out, there's a whole raft of them. A really good one is called FluentD. It's part of I think it's a CNCF project, so it's it's well respected. There are different drivers that you can use to run FluentD with Docker or Kubernetes or different environments. Actually, strangely, I've been reviewing the last set of reviews for my Learn Kubernetes in a Month of Lunches book, which is the sequel to this one. I do a whole chapter, a very similar chapter to this, but it's all slightly different in Kubernetes. So you need to approach it differently, but you still use the same principle. You still can use fluentd to pull the logs from Kubernetes, which is a slightly different way of doing things, and then you put them somewhere central. So fluentd is really the middleware component. So you hook up Docker to write logs, to push logs to fluentd, and then you can configure fluentd to do lots of different things with it. So fluentd can use different stores to push the logs onto. Okay, so here we go. Let's go and run this stuff. I'm probably already in the right directory. Am I? I'm in exercises, so I'm going to go into fluentd, and I'm going to run a fluentd container. So all that is, it's just a container with the fluentd software already in there. Fluentd kind of listens on a port, so the conventional port is 24224. And that's why Docker can be instructed to push logs for other containers. So just like when I ran my my time check application and I had my logging configuration and I set the maximum number of log files and all that sort of stuff, I can include a log driver. And the log driver here is saying, my log driver, I want to use fluentd, which means that Docker will expect to find a fluentd available on port 24224, and it will push the log entries there instead of writing them to the JSON file. So when I run this one, I've just run that there. So it's up and running, detached, so I don't see any of the logs. If I go and look at the logs for this one, time check 5 is the name, then I get an error. So I'm going to get an error saying the configured logging driver does not support reading, which basically means I don't get the JSON logs as well as the fluentd logs. So in this case, fluentd is getting sent the log entries instead of Docker writing that JSON file. So Docker's pushing them to fluentd. So, and fluentd doesn't give me a way to view them directly. But this particular configuration of fluentd, it's just another relay. So I'm just taking the logs that I get from the container and relaying them back out inside the fluentd container. We'll look at the configuration in a second. It kind of takes a bit of getting used to, so I'm not going to go into a ton of depth, but I'll show you the main pieces. What I have got here is I can see my information log that came out of my application. This is the actual log entry. But I've also got a bunch of other stuff that fluentd adds for me. So I've got the timestamp, I've also got the name of the container, and I've got the container ID. So fluentd adds this metadata on top, so I can identify the container, which I don't get just from the JSON log file. So as well as collecting the log entries and putting them somewhere central, it extends them with this extra data, which means I can identify the source of them. So that's kind of useful when I'm pushing everything into a central place. Okay, so fluentd itself at the moment is running, it's collecting the logs, and all it's doing, it's writing them to its own standard output. So when I look at the logs for fluentd, I'm seeing the output that's collected from everything else. That's only kind of useful to show you how fluentd itself works. It's much more useful to forward the logs to somewhere central. So I'm using Elasticsearch for that, which is a document database. So if you're not familiar with Elasticsearch, it's an open source, like enterprise grade NoSQL database, been around for a very long time. You can run it in a container really nicely, and you can cluster it, so you could run it in a production grade as well. Let's show you what the model looks like here in this application, in this picture of the application. So in this case, what I'm going to be doing is I can run multiple different containers. As long as they're putting things to standard out, then Docker's going to collect all those log entries. So one of those containers is a modern application that's just writing to standard out anyway, and the other one is using a log relay utility, but the end result is the same. Those logs get collected by Docker and sent onto fluentd. And then what happens is fluentd then is configured to push those logs into Elasticsearch. So each log entry becomes a document in Elasticsearch. The reason why like a NoSQL document database is really good is because it indexes each document, so it knows each field and you can search on each value. But although each document has a known structure, the structure across documents doesn't need to be the same. So, some of my log entries might have different fields than others, and that's fine. Like, Elasticsearch doesn't care about that. It's not like a relational database where the structure has to be the same, across rows. And then the partner of Elasticsearch is Kibana, which is a front end made by the Elastic team as well. Again, it's open source. It's genuinely enterprise grade software. You can just drop in running a container. It understands about Elasticsearch. It gives you a really nice way to visualize your data and to search for things. So let's go and have a look at this. So I'm going to run this first, and then we'll have a look at some of the configurations. So I'm going to clear down all my containers because I don't need any of those. Get a little bit more room. And then I'm going to start my logging stack. So I've got this fluentd. I think I'm probably need to go back to exercises. Yeah, cd So let's check them in the right place. Yeah, so inside here, I've got a Docker Compose file that we'll take a look at when everything starts running. So it's creating Kibana, FluentD, and Elasticsearch. So those are the components. So let's have a look at what they look like. So inside here, inside my FluentD Docker Compose, nothing complicated in here, like nothing that you haven't seen before. So FluentD is, again, these are all my images because I add the make sure that they work across platforms, so you can run the exercises, Linux, Windows, ARM. So there's my FluentD, there's an environment variable telling it which configuration to load. And then it loads that from a local file. It exposes those ports. Then I've got Elasticsearch. 9200 is the default port to talk to the API, and then Kibana and 5601 is the default Kibana port to use the UI. And that's about it. There's nothing, there's nothing particularly clever about that. So it's just running in those three components. So let's close this. If I now run my my logging, the container that generates a whole bunch of logs, so I'm going to run, I cleared down the previous containers, so there's nothing running now except my logging infrastructure. If I run my time check container with the FluentD log, so it's the same configuration as far as Docker is concerned. It's running this container and it's taking the log entries from standard out and it's pushing them to FluentD. But now FluentD is configured differently. So instead of just writing out and relaying the log entries it gets, it's pushing them to Elasticsearch. And that configuration that it's using just tells it how to find Elasticsearch. The whole FluentD pipeline has pluggable components. So you can transform data, you can push it to different sources, you can do all sorts of really cool stuff. And we'll see some of the examples in a second. So let's give that a moment to be ready. It should be ready by now. So if I go and look at 5601, which is the Kibana port. So if you're not familiar with these tools, that they crop up all the time. They're really useful for even just doing little quick things where you wouldn't normally necessarily run a fully replicated database. So if I want to do some analytics and show some users, give them some self-service analytics, it's a really good way of just kind of proving out that stack. So I'm going to click on Discover. This is all in the chapter. Let me make sure I'm clicking on the right things and typing the right things. So FluentD is the name of the document collection. So the collection is just where all the documents live. So we've found that. Every document has a timestamp field, and then Kibana can use that to show me when things came over time. Kibana is already configured to go and talk to Elasticsearch, so I don't need to do anything there. I've already created some data. I've created some log entries. So these are the things that it knows about them. These are the fields that it's found in the log entries that are already there. If I click on Discover, then I'm going to see a whole bunch of logs. This graph here tells me the number of entries that are coming in, the number of documents coming in over time. And each of these documents is a log entry. So if I open this up, we will see here, here's my log entry that came out with my time check. It came from standard out. So again, that information comes from Docker, feeds into FluentD, and then FluentD adds its own metadata. So I've got my full container ID and my container name. So and the type this is an internal field that Elasticsearch uses. So these are all kind of really useful things, but there's more that I could add in here. So I don't know, there's only a certain amount of information here that will help me find the particular container and get the log entry and stuff like that. So it's not as useful as it could be. So if I go and switch back to my my chapter here, so that's what we see. I can go and look at those log entries. The index is just the name of where all those things are kept, and we can see that how all this stuff is set up. So let's go and check out the Elasticsearch configuration, so we can see how this stuff works. So I've got this is the Elasticsearch config that I'm using. This is FluentD syntax. It's a little bit awkward to get used to, but I'm just going to focus on the main things here so you see how this works. So this match field lets me say incoming log entries. I can filter them out based on certain criteria, which we'll see more in a second. This is saying match everything that comes in from whatever source. Anything that Docker forwards to FluentD, I'm gonna match, and it will run this block. And what we're going to do is we're going to take a copy of that log entry, and we're going to store it in Elasticsearch. So the type here, this is the pluggable bit. There are different sources that you can push things to, different targets rather. And this is the host and the port, and this is the format that I want to have in there. And I'm going to include this thing called a tag key, which is something that I can configure in the setup of my application. So it tells it how often to flush. So it'll cache things for 1 second and then push them out. And that's about it. So it's also storing to standard out. So I can get multiple copies of the same log in either standard out or Elasticsearch or whatever. So it's not super intuitive, but actually it's not that difficult. And once you've set it up once, you're probably just going to not fiddle with it too much. So it's a nice and flexible without having to require too much tweaking. Okay, so this is how it looks when I'm pushing things into Elasticsearch. I can, with Kibana and Elasticsearch, I can search across all of those documents for anything. So if I've got log entries that are writing, a specific unique ID for an error, I can type that into Kibana and it will show me the log entry that generated that reported that error was generated. And you can do this thing where you tell it to show me the log entries around that entry, and you'll see the entries before and after that error condition happens. So it's really nice way to, it's a really nice stack if you're not familiar with these things. And you can, like you've just seen, you do your Docker Compose up and you can start playing with this and seeing how it looks. But I'm going to run a real application here. I'm going to run my NASA Astronomy Picture of the Day app, which is just configured in my Docker Compose file. That's going to create all the components that, again, if you're familiar with the series, there's a web UI, there's an API in the background, which caches the data from NASA, so we're not always hitting their API. And there's another API that records when the site gets used. So there's three little components. They're all configured to use FluentD. So if I go and check that configuration, so open up my, let's close down the terminal for a second. And inside here, inside my image gallery, these are the details that I put in when I did my Docker container run and told it the logging driver. This is how you do that in Compose. So this is my access log, which is the Node.js component. The logging driver is FluentD. And then I'm passing this additional tag. So when I pass my logging options, I can give some extra metadata. So FluentD knows how to find the container ID and the container name, but I can also give it some more stuff. And what I'm telling it here is, this is like the name of my, this is the name of my application. This is the gallery application. This is the name of the component or the service within that application. This is the access log. And this is the image name. So the full name of the image, which Docker will provide. So when this stuff goes into FluentD, it's going to have some additional metadata saying that, identifying that it came from the access log component. And then the configuration for the others is the same FluentD driver. And the tag says this is the gallery, this is the image of the day, which is the API, and that's going to have the image name as well. So they're all passing this extra metadata. And in my next set of FluentD config, I'm going to be pulling that stuff out. So let's go and see how that looks and get rid of that. So if I go and browse to 8010, which is my my image gallery application. So here we go. What have we got today? We have got the International Space Station transiting Mars. That's pretty cool. Okay, so if I hit refresh a few times, then I'm not going to NASA every time because my application is cached, but there are logs being written all the time, so the access log component is going to write a log for each time that I hit that. If I go back to Kibana and scroll back up and make this a bit bigger and click on refresh, then what I should see is a whole bunch of things coming through here. Do I see those coming through, or do I need to do something else? Let me go back here and see what I've got. So adds a tag to each done. Have I missed a section here? This is good, isn't it? Okay, so I've done that to FluentD. I've done that. Probably just takes a moment to come through. So let's go back and try again. I'm filtering the logs. Yeah, so I should be seeing these logs. Oh yeah, so that's still running. So I'm still seeing all that stuff. Let's browse down and see if I can see my access logs. These are all my timestamp things. Here we go. Here we go. So it's just a little bit further away. So here's my image gallery access log. This is the log entry that just came out. It came from Standard Out. I've got my container ID and my container name. I haven't got the extra stuff in there about the image name or the application that this is part of, because I need to configure that in FluentD. So the tag that I put in there, the extra metadata, is coming from Docker to FluentD, but it's not doing anything with it yet. It needs to be told what to do with that tag that comes in. And that tag ID is a generic thing that you can put as part of your logging option. And then whatever logging driver you're using, whatever component is pulling the logs out, you tell it to do something with the tag. Okay, so that's the wrong thing. Let's go back here. So in this case, now I want to add some of that metadata in. So I've shown you that how the tagging stuff looks, but I also need to do the FluentD part of this. Okay, so if you're not, yeah, there are lots of other options. FluentD is only one. You can use other things like Greylog and Splunk. The logging driver is just that's part of your container definition or as part of the engine definition. So I can tell everything to go to FluentD, and I don't need to have that specified in my compose file, which means in between, dev and production. Dev, everything goes to the JSON because that's what the default is for the daemons in dev. And then in production, everything goes to FluentD or Splunk or whatever. Okay, so let's have a look at this extra configuration. So inside here, this is where I'm going to be doing the filtered part. So what am I going to be doing here? So this configuration, I'm going to be filtering out the access log components. So all those bits that come from the access log to say someone's hit the site, someone's hit the site, someone's hit the site. We're going to filter those out, send those to standby out, and put everything else to Elasticsearch. So if I go and look at the FluentD filtered file here, so inside FluentD folder, here's all my configuration. If I look at the filtered configuration, what I've got inside here is the filters that I've got inside here. I'm filtering out the gallery component. So the first part of the tag that identifies the application itself, the part of the app that it's running. So all my image gallery containers, they have this tag that is prefixed with the word gallery. So this is saying anything that comes from the gallery. I'm going to use this record transformer to pull out the parts. So the application name is the first part of the tag, gallery. The service name is the second part of the tag, which would be access log or IOTD. And then the image name is the third part of the tag that Docker provides. So that setup of the tag inside my compose file, that filters into FluentD. And this is telling FluentD that there are 3 parts to the tag. Pull them apart and put them in these fields. Okay, and then what I'm saying down here, when I look at this, is for the now that I've got the record and I've got the components, I'm going to filter out the access log components, and they're going to stand out. And then it's like the first match wins, the most exact match wins. So if there's a log entry from the access log component, that's going to go to stand out. And if there's any other log entries, they're going to go to Elasticsearch. So if this is anything from the gallery, will come in and hit here and go to Elasticsearch. But it won't have the access log because that's going to just to stand that out. And there's another thing here that says we're going to include the tag, so that will get all the way into Elasticsearch as well. So when I do the new deployment, FluentD now is going to have this configuration. It's going to send logs to different places depending on the source of the log, which comes from the tag, and it will include the separated parts of the tag as fields in Elasticsearch. Okay, so close that down. So I'm going to update my FluentD config in here. So that's just passing in the override, the Docker Compose override, telling it to use a different configuration file, which is the one we've just done. And I'm going to update my application to include the logging override stuff. Okay, we'll let that run. And that logging override, let's open that up too. So for my application, my image gallery application, I've got this override logging. And all this does is it's an application setting. So the image of the day application itself has been turned up the logging level. So I'm just saying that I'm generating more logs from one component, and they're all going to hit FluentD, and it's going to show all those, but it's going to filter out the ones from the other component. Okay, so we're up and running. So let's go and check the application again. Go back to my image gallery. So it's still the same application. These are new containers with new configurations, but the content's going to be the same. If I go and look at Kibana and click on Discover again, I should be a bit more patient this time. So if I click on Refresh, what do I see? So I see my IOTD here. That was from 10 seconds ago, so that will be a new one. Okay, cool. So I've got the extra stuff in here. So I've got my image name. So this comes from FluentD from Docker via FluentD. So Docker sets the tag, it includes the image name, FluentD takes that apart and puts it into a separate field. So that metadata is flowing now all the way through. I've also got my application names. This is the gallery application, and somewhere here, this is the service. This is the service part of the application. So I'm seeing all these image of the day things, and then I've got my log entry in here. So I'm building up the extra metadata. There's a limit to what you can include, so what you can put in the tag. There's only a certain number of fields, but image name is a really good one. So I can correlate. I've had a problem in my monitoring, and I can pinpoint when that happened, and then I'm going to go and look at the logs, and I've got an error ID that a user's given me or whatever, and I'm looking at the logs around that time. And I can see the exact image version, so I can make sure that I'm running what I'm expecting to run in, and then I can get someone to try and reproduce that using exactly the same image tag. Okay, cool. And the other thing, of course, I can filter this stuff out. So I can these exclamation marks are telling me that these are new fields that the Elasticsearch, that Kibana didn't know about. So when I created my index, it knew about a certain number of fields from the log entries, but there are more. So I just go to my index patterns and I can click refresh, and it's going to reload all the fields that it now knows about. So if I go back to discover, and inside here now that it knows about those fields, so it now knows about the container name and the image name, I can add those as a filter, and I can filter out just to have a particular set of images and all that sort of stuff. So I can filter out, here's the image that I think is the problem. Let's look at all the log entries for that one. So you get this really nice thing. So let's clear these down before I get confused before the next demo. Okay. So that's the kind of thing you can do with very little effort. So FluentD is just a standard component that I'm dropping into my application, and so is Elasticsearch and Kibana. Those three things all work together. So FluentD knows how to talk to Elasticsearch. I can configure it in interesting ways with a little bit of research and digging into what options are available to me. But actually, this example that you've got here is a pretty good starting point. I've got the image name and all that sort of stuff, and then Kibana knows how to talk to Elasticsearch, and so I've got the whole kind of logging stack without having to do very much. And then I just configure my containers or my engine as a whole to use FluentD. Okay, so let's go down here. So you'll see all this stuff here. There's no access log containers. There's no access log logs anymore, but they're now going to stand out, so I could still see them if I wanted to, which I do here. Did wonder if I was going to do that. So remember that the configuration sent everything to Elasticsearch unless it was from the access log. So if I look at the FluentD container, the access log entries were being sent to standard out. So I see them in the FluentD container, not in the original application container. Okay, so that's the access log bit, but the fields still make it through there. So I can still see the service name. I should see the image name in there somewhere if I could see it. It probably is there, I just can't see it. So yeah, there's my image name, DIAMOL CH18 access log. So all that stuff still happens. Certain levels of processing happen to the entire record, the entire log entry, and then I can send them to different places. Okay, so let's clear this down. So that's the stuff we've seen. We can do matches, we can do filtering, we can enrich the data as it comes through FluentD. It has a whole pipeline with more things you can plug in. I'm just showing you the basics really, but this is a good way to get started. And there's one final exercise for this chapter to put everything back the way it was. And let's see, we're going to kind of approximate a situation where I'm writing those log entries to standard out because everything's going fine. I don't really need to dig into them very much, so they're just going along just fine. But then something happens to my application, like maybe it slows down, or maybe and I want to dig into the logs to see how long it's taking to do some other part of its processing. I want to increase the logging. Well, typically, if I wanted to increase the logging, I might have to edit the configuration of the application itself. And we've talked about that in previous episodes, that updating config would be setting a new environment variable value or loading a new config file into the container. Not every application is going to watch config files for updates. So effectively, it's a restart of the container if you're going to tweak the config, which means a replacement container because it's a new container environment. And the problem with that is if it's logging, if a component's behaving badly and I try to increase the logging, but by increasing the logging, I remove that component and start a new instance, the new instance might not have that problem. So by making sure that I could, if I wanted to, log at the highest level from my applications, as long as that's not too expensive, and then just discard them all in FluentD. And when I need to bring the logging level back up, I just change the FluentD config. So my app is still pushing out all these logs, but most of them are being ignored. If I want to see them, I can change what FluentD is bringing into Elasticsearch. I don't have to restart my application container, so I won't lose whatever state it's currently in. I can get the logs out as it is now. Okay, so clear this down again, and I'm overriding the configuration here. So we're going to look at the configuration. It's maybe the second time round it'll be a bit more straightforward. So I'm now using the full configuration, the full Elasticsearch gallery conf. So we've seen a little bit of this. It's not a great format, but you get the idea. So inside here, I've now got I'm adding another filter inside here, which is adding my container name. So this would get the actual, remember inside the container itself, the host name is the container name. So it's adding that FluentD container so I know where my FluentD container is. Then I've got this transformer, same thing as before. I'm expecting a tag to come in from Docker with these three parts, and I'm splitting them out to the app name, the service name, and the image name. If I scroll down, what we'll now see is I don't have that match for the access log. So I've taken out that match, which was pushing the access log entries to standard out. So now everything that's come from the gallery will go into Elasticsearch. And same as before, I'm including the tag, and I've got my flush interval set. And anything else, so if it isn't the image gallery, now it will go to null, which just means it just gets discarded. So that's how we can bring things into FluentD and forget about them. So there's still a certain amount of cost. There's a cost to the application in compute time to write log entries. There's cost to get it into FluentD and then for it to be ignored. So you need to balance the fact of, is this being able to increase the logging on the fly without restarting my applications? Is it worth the extra kind of latency that I'm introducing along the way? But it may be for certain parts of your application. Okay, so now if I go and let me just check that I need to do what I'm going to do. So I'm going to go back to my application. Yeah, so let's go here, back to the image gallery. We'll look at the International Space Station again a few times. If we go back to Kibana and refresh, the first thing we should see is that all the time check application logs have gone. So they're now hitting the filter that says you're not part of the gallery application. That's the only thing I'm storing in Elasticsearch. So they go to null. So all I'm getting is the bits from my application itself. If I refresh this again, we should see all the components coming through. So here's my my image controller, which is coming from, again, I've got my down here, all my different pieces. I've got my image name. I know which FluentD container did the writing, which is a useful thing to have in debug. Again, there's a certain amount of cost in storing that data, but it's useful for tracking things back down again. There's the actual log entry that says from the controller part of the application that the get image has been called, and this is the IOTD. And we should see now that all of those entries are coming through from all the different parts of the application. There's my access log. So the access log now is back up. I'm getting all those log entries. I'm getting the debug level logging from the API, which we saw in those log entries. And I've now got my access log stuff coming from the Node.js API. So I've maxed up the logging without having to restart my applications. And I'm just doing that by tweaking my filtering config inside FluentD. So yes, it's another thing to learn. But if you think about what you used to do in the old days to collect and forward logs, it would be some kind of proprietary system that your applications had to behave in a certain way, or your collection system had to know about the vagaries of each different application. So I'm going to go onto this VM, I'm going to look in this folder and collect the log files, and maybe have an agent running that will push those things out. So it simplifies all that stuff. So you need to put the smarts into your application container so that the log entries come out from the container, and then the rest of it is just in this nice simple logging format, where you can do all this extra stuff, this filtering and enriching and all that stuff. Okay, so back here. So we've seen how all that stuff looks. So yeah, and the other thing about this is slightly imperfect. So I've talked about adding latency. The other thing is you need to bear in mind is as you're occasionally you're going to need to restart FluentD, because if I'm applying this config setting, I'm not restarting my application containers because I'm not changing their config to up the logging. But I am restarting FluentD because I've changed its config, which means that there's going to be a period of time, hopefully very small, and depending on how you're running at scale, you might not have this issue, when there might be lost entries, because I've told Docker to send all the logs to FluentD. If there is no FluentD running, Docker just loses the logs. So rather than crash in a heap, those logs just get lost. So there is the potential to have a period when there is no FluentD available during an update, where the log entries get lost, but that would unlikely in a production environment because you're going to cluster all these things. So, and you're going to have your kind of rolling updates that we've already covered. So my rolling update of FluentD will make sure there's at least one container running, and that will process the logs. And it doesn't matter which FluentD container picks up the logs because they're all going to go to Elasticsearch. Okay, cool. So this is a bit about the kind of wrap up here. This is called the Efk Stack. So if you've heard of the Efk Stack, which is Elasticsearch, Logstash, and Kibana, it replaces the Logstash bit with FluentD, which is just a nicer integration with a containery way of doing things. FluentD is pretty lightweight. It's got a whole bunch of integrations. So there's like a couple of hundred things you can plug it into. If you don't need all that stuff, there's an even lighter weight version, which is what I use in the Kubernetes book, called FluentBit, which has a smaller number of integrations, slightly easier configuration syntax, maybe, depending on whether you like angle brackets or not. Same principle. It sits and collects the logs, and it can forward them somewhere else, and it can enrich. And there's a pipeline inside the logging driver that will that can enrich them and filter them out. So here's how this looks in like a production environment. There's a Fluentd container running on every node and collecting the logs from that node. So when I'm running in Swarm or Kubernetes is slightly different, but there's still a collector running on every node and picking up the logs either from the container runtime or from wherever they get used. Kubernetes is a slightly different way of doing it. They all get picked up and then they get sent to Elasticsearch in a production environment. You run Elasticsearch clustered, so there is no loss of data, and it all gets replicated around the cluster. I think Kibana itself is really lightweight, so you don't. It's stored when you can build up graphs and you can build up dashboards in Kibana, and you can save your searches and all that sort of stuff. But all the data that you put in gets saved in Elasticsearch, which you have got now highly available in a cluster. So, if your Kibana instance dies, it doesn't matter. The orchestrator will start a new one and it will have all the same state. Okay, cool. So, finish with a note of caution. So, so when you start talking about this stuff to teams who have got their own ideas about logging, because, logging's been around forever. Your applications are always doing logging. You already probably have some kind of store and forward processing model to get a centralized logging search database. You tend to say, look, here are the layers we're going to have here. Docker will use a logging driver, and then Fluentd will get these things, and it will push them to Elasticsearch. And then they say, well, actually, why don't we've got this thing, and we're going to have our applications write directly to Elasticsearch. And that's fine. Like, if you want to do that, you're going to cut out the latency, but you also lose the flexibility. So bearing in mind that what I've got here, when all I'm doing in my applications is writing to the console, writing to standard out. And then everything else happens configuration outside of the application. So I don't need to change my application to switch to Greylog or Splunk. I'm just going to change my Fluentd configuration. If I want to use some other forwarder rather than Fluentd, I'm not changing my applications. I'm just changing my my configuration of the Docker engine to use a different logging driver. So the cost of the latency, the reward for that is that you've got all this flexibility. You don't need to change your code, your application config. Even your Docker configuration, you might just be changing how you're using Fluentd. And Fluentd is like a really popular way of collecting logs. It's the main thing that people do in their containerized applications. So if you do it the other way, you're going to save yourself some processing time, but you lose all the flexibility. So you've effectively inside your inside my .NET application or your Java application, you can use an Elasticsearch library and you can write your logs directly to Elasticsearch. But you've lost the opportunity to do that enrichment, which adds in things like the image name, and you've lost the opportunity to do filtering and matching and that sort of stuff. So you've saved yourself, a few CPU cycles and a bit of network time, but you've lost an awful lot of flexibility, which you're bound to use sooner or later. You're bound to want to do something slightly different, and if you can do it in a central place in your Fluentd config that affects all of your applications, then that's a much neater way of doing it than having to go and edit all your config or update all the client libraries for Elasticsearch in every application or whatever. Okay, cool. So if you've seen previous episodes, you know that the way the chapters work in the book, there's a whole bunch of exercises that you're meant to kind of go through because it gives you experience of using this stuff. That's what I've been doing, going through and finding, do some discovery, see how this stuff works for you, go and look at the files behind everything. And then the lab at the end is meant to stretch you and ask you to achieve something without giving you too much assistance. So I don't go through that in the episode because it's meant to be a way of reinforcing your knowledge and doing a bit of exploration by yourself. In this case, we're doing some other different application that you're gonna work into the Efk stack, and there's some examples in there. We can just look back to the chapter and see how to do that stuff. And there's a sample solution up on GitHub if you do find that stuff a bit awkward. Okay. Okay. So Michael says, thank you for the excellent content. Thank you, Michael. Kubernetes next. Yes, so Kubernetes is next. So the Kubernetes book is, the first draft is all done. Actually, we've been through 2 sets of reviews. If you don't know the book writing process, if you're thinking of writing a technical book, I can heartily recommend Manning. They're really great to work with. They have such high quality bar. So you have all these review processes. So I finished, I put the last full stop in the word processor a couple of months back. But it probably won't hit the shelves until January or February. So my plan is that when this series is done, I'm gonna still be on YouTube. I'll be doing a slightly different series, and then next year, which will be 21, if you're watching at some point in the future, the Kubernetes book will be out. I'll do a Learn Kubernetes in a Month of Lunches series like this to guide you through that book. So yes, Kubernetes is next. Fluentd conf. How do you add node info in a Swarm cluster setup? Oh, good, nice technical question. So I'm trying not to mix up too much in these chapters. So we did a stuff about Swarm, and then when we moved on from Swarm, we've gone back to ordinary Docker engine. Partly because I'm aware that a lot of people don't use Swarm, but they do use Docker, and partly because I would have to get you running Swarm in different ways. So it's all done in that fluent D config. So how you pass things through, like I said, when we pass the image name in the tag, it's the same thing. So the node name, I'm not sure if that's one of those things you can pass through, or whether it just comes from fluent D itself. So if I look at, let me go back to here. Yeah, so I'm not getting the node name by default. I'm getting the fluent D container name. So it's going to come through as additional metadata. So you're going to need to configure all that stuff up. I don't have an example for that, but you're going to flow it either in through the tag or in the fluent D config itself. So we can pick some of that stuff up. Okay, and so this is a good one. So when will you use EFK and when will you use Prometheus and Grafana? So you're going to use them all. So you're gonna. The idea is that my logging is I don't lose any data in my logging. So every log entry is going to get collected, stored, and then indexed, so I can search on it. So that's happening. That's one set of investigative material that I've got available to me. And then Prometheus and Grafana is the ongoing dashboard that I'm using to kind of monitor the health of the application. So that's the thing that gives me the graphical view that tells me if things are good or bad. And if things go bad, then I'm probably not going to get the lowest level of detail from Prometheus and Grafana. So that's when I go and look at my logging. So it's not one or the other, because you're probably going to need both. The monitoring part is probably the newer part. Your applications probably already have logging, and you're just tweaking the way that works when you move to Docker. The monitoring part is the nicer bit that you can add to get that kind of live dashboard without, looking at logs is a very reactive thing. So I'm searching over a period of time. I'm looking for an error log entry, or I'm looking for an error code or a logging code. The Grafana dashboard is very much, this is the live heartbeat of our application. So, we're confident everything is good. And then logging is for your kind of diagnostics, really. Okay, so let's go back to this one, not that one, this one. So that's it for episode 18. So that's the end of the kind of the technical bits around how you integrate your application so it works nicely with Docker. We've got 2 more episodes, and tomorrow we're looking at reverse proxies. So this idea that we've been running tons of applications in Docker, and we always use these random ports. Like, I publish port 8081 and 8086 or whatever, because only one component can list on a port at a time. Obviously, in production, you're not going to have a whole bunch of websites that use random ports, because no one can access them. The way that works is you have a single component that receives all the traffic, and it goes and fetches those the actual source from the other containers that are running in your cluster or on your server. That's a reverse proxy, and we're going to cover that tomorrow. So tomorrow's episode 19, and then we've only got one more to do. So so I hope that was useful. So today was all about logging. I hope it wasn't as boring as it might have been other times you've studied logging. So my name's Elton. This was Learn Docker in a Bunch of Lunches, and hopefully I will see you next time to learn about reverse proxies. Okay, thanks.